Hello and welcome to Cyber Skills Live. My name's Daniel and I'm a climate conscious engineer. You're joining Craig and I for this very special Cyber Skills Live. Now Craig and I love everything tech and data. And today you're going to be using data science skills to help fight climate change.
That's right, and today we're coming to you from Glasgow, the home of the COP26 climate conference. World leaders are coming together for important talks about the future of our planet. Thank you for joining us. We have groups joining us today from across the world and across Scotland as well. This is your chance to learn about data science skills and climate change in the classroom. You're about to get hands-on with data. So what is data? Well, data is information. It's things that we know. It's things like facts or numbers, things that we can measure. And data science is being able to collect that data, being able to understand it and use it to make decisions. We need more people who understand how to work with data and how to use it to make better decisions. But can we use data to save our planet?
We're in a climate emergency. To give us the best chances at reducing the impact of climate change, climate scientists have stated we need to secure global net zero by 2050 in order to keep the global temperature rise under 1.5 degrees. Now, to do this, we need to accelerate the phase out of coal, we need to curtail deforestation, we need to reduce our usage of fossil fuel transport, and we need to encourage investment in renewables. That's what we're going to focus on today, renewable energy.
You'll use real-world data sets to create a proposal for a renewable energy system for your school. You'll need to work with energy usage data, geolocation data, satellite imagery and Earth observation data collected by NASA.
So, are you ready to use data to save our planet? Let's plug in the numbers and use data science to reduce your school's carbon footprint.
Thanks for joining us. We're really excited about this one happening during COP26. So as world leaders, delegates and activists debate the future of our planet, literally around the corner from us, you are going to be our data scientists exploring how renewable energy can reduce your school's carbon footprint. What you need to do now, if you haven't already, is go to this website here, cyberskillslive.com, and click Start the Live Lesson.
Yep, all you need is a web browser to take part today. So go to cyberskillslive.com and click Start the Live Lesson. Once you've gone onto the website, it'll ask you to sign in. So you need to sign in using your first name and choose your school from the drop-down list. Now we'll be tracking your progress as you take part today, and we'll be giving you hints and help along the way. So don't worry if you fall behind or you get stuck or you've never done anything like this before. You know, this is maybe your first time doing data science, maybe your first time working with renewable energy. Don't worry, Daniel and I will be able to give you some hints and guidance along the way. So we'll help you catch up. So when you sign in, make sure you type in your first name and choose your school from the drop-down list. We've made sure that everyone's schools are available today. I know that there's going to be hundreds of you hopefully taking part this morning. So if your browser goes a little bit slow at some point or a question isn't updating, don't worry, just wait a minute or so and then you'll be able to continue. So Daniel, I think we've already had quite a lot of people joining already.
Yeah, I can see loads of you joining already, and we're going to be following along with your progress, giving you hints, shout outs and guiding you through plugging in the numbers. And speaking of shout outs, you're joining us from all over Scotland and further afield. So let's give a few of you a shout out that I can see are taking part today. So a big hello to Falkirk High School, Prestwick Academy and Robert Douglas Memorial School.
Thank you for joining us. I can also see Linlithgow Academy. Thanks for taking part today. Queen Anne High School and a primary school, Lamlash Primary School. Thanks for taking part.
A few more joining us, playing along today. We've got St Columba's High School, Stirling High School, Ballgreen Primary School and Denny Primary School. Thanks for joining.
Big classes joining from St Columba's and Stirling today. Thanks for joining us. Langley Primary, thank you for taking part. In fact, Daniel, we've got the spread right across the country this morning. We've got everyone from Langley Primary in the Scottish borders all the way up to schools in Shetland. So thank you everyone for taking part.
We've got a few colleges and universities taking part too. So a big hello to people joining us from the University of Edinburgh and Manhattanville College in New York. You're not the only international participants we've got today. I can see there's people playing in Pakistan, India, and Ireland. So thanks for taking part. Hope you enjoy it today. We're going to have more shout outs later on too. But before then, what we're going to talk about today is we're going to answer a question. And the question that we're going to answer is how much energy could a solar panel on your school's roof generate? And what impact would that have on your school's carbon footprint? Now, every school taking part today is going to have a slightly different answer. I reckon a school in India is going to have quite different numbers to a school in Ayrshire. So we're going to help you gather the data that you need. We're going to help you analyze that data. And then you're going to do some calculations to come up with an answer based on real life numbers for your school. So what you need to do now is follow the instructions on your screen to start the investigation. And our virtual data scientist and climate activist Sunny is going to guide you along the way.
And we want to see your results as you work through the activity. So if you're an adult, you can tweet us at Digital World HQ, or you can tweet at data_schools, and make sure you use the hashtag DataSkillsLive and hashtag COP26. We love to see your messages, your photos, and the results of your calculations as well. So thank you everyone for joining us and taking part. Daniel, I can see that there's still people joining at the moment. So don't worry if you are running a bit late, if you have only just started, you've not missed anything yet, we're just getting started. You just need to go to cyberskillslive.com and click start the live lesson.
We've already started to collect some data today, and we're collecting a bit of data about you. We can see your names and we can see your avatars. And the reason why we've asked for your names and you to choose an avatar is so we can go to this. This is our activity feed, and this is what Craig and I will be watching to analyze all of the data that you're going to send to us. So let's say hello to Russell at Pressway Academy. You just answered a question correctly.
Mr. B at St Columbus High School, you told us why electricity is less used at the weekend, so we'll come to that soon. Thank you for taking part.
T at Langley Primary, you've just met Sunny.
Finlay at Prestwick Academy, thanks for taking part as well. And Hannah at Prestwick Academy as well, thank you for taking part.
And I can see we've got someone with the initial P joining from Ball Green Academy, and you've just met Sunny as well. So we'll be coming back to that activity feed every so often and giving you shout outs. So watch out for your avatar and watch out for your name appearing on the activity feed. At the start, we also asked you a question. We asked you how you got to school today. So we collected that data by asking you the question. And now what we're going to do is we're going to analyze those results to try and understand what mode of transport is the most popular. So let's take a look at that data.
So our first bit of data analysis today, Daniel, one way we can visualize this data and understand it is to put it onto a chart. So this pie chart is an example of data visualization. So rather than me just reading you out, what people have voted for each type of travel, I can just show you the results on this chart, which should make it easier to understand. Daniel, what can you see on this chart?
Yeah, so it looks like almost half of the people joining us today are in the sort of the green segment, and the green segment is either walking, running, or rolling. The next most popular mode of transport is by road, so it looks like about half of you have come either by car or by bus. Not so many people taking bike, train, or something else today.
Quite a lot of people travelling like in some form of active travel though, so that's a good sign.
Yeah, it looks like it's about 50-50 between active travel and by road. Now this is live data, so as more people join us, more people answer the question, these segments are going to change size and it's going to update. So we might come back and take a look at it a bit later, because I can see a lot of you are just joining and you've not got to this question yet. Well, don't worry, your numbers are going to get included later on.
It's brilliant. So Daniel, what is the first part of this investigation?
Yeah, so the first part of our investigation today is to work out, well, how much electricity do we need to supply to your school? How much electricity does your school use every day or every year? Now, we could get that data in a few different ways. You could look at your electricity meter, and then you could look at it again and you could see, well, how much has it gone up by across a day or a week or a year? Or you could even ask your head teacher just to show you the electricity bill. You know, that's one way to find out the amount of electricity that your school's using.
Yeah, good luck with that.
Good luck with that. they might show you. But you know, even if you were using your meter you found and you were looking at the number, if you wanted to know how much electricity you use over a year, well, you'd have to take a measurement today and then take a reading in a year's time. That's going to take too long. We want the answer now. So, you know, as data scientists, we can learn how to work with data sets that will tell us what it is we need to know. Now, we did a bit of research into this, and it turns out that most schools use a similar amount of electricity, at least within the UK. And there's data sets available that have really detailed information on school electricity usage.
So let's use smart meter data to give us an idea of how much electricity a typical school might use each year. So we're going to be using a data set to do this. So what you're looking at right now is data that is being collected by someone else. So it's been collected by Dundee Council, but it's been shared so that other people can use it. So they set up electricity meters in every single school in Dundee, and they recorded how much electricity was being used every hour for a whole year. And then they put all that data into a structured format. So in this case, they put it into a spreadsheet, and they put it online for anyone to download and use. And that is the real life data that you're looking at and using right now. And because this data is available for anyone to use, it's called an open data set. So Daniel, why is it better to use an open data set rather than trying to just get every school who's taken part today to work out how much electricity they're using?
Yeah, I suppose there's a few reasons why you might choose to use an open data set, but the main reason we're using it is really to save time. You know, rather than having to buy equipment or waiting a whole year to read meter readings, we want to know the answer now. And by using open data, as long as that data is high quality and as long as it's been recorded correctly, which, you know, it should be if it's come from the council and there's lots of people using it, that means loads of different people can use that data to answer different questions. So for example, this data set might also be used by electrical engineers who are planning new schools to give them an idea of how much electricity might be needed. They're going to need to know how big a substation to build. They're going to need to know, well, how thick do the cables need to be to transmit the amount of electricity required for that school.
So I know that you are working through this activity right now. How are people getting on, Daniel?
Yeah, let's take a look at our activity feed and have a look. So I can see that we've got quite a few people that are getting towards the end of this phase. See that Elle at St Columbus High School has just told us why less electricity gets used at the weekend in schools. And I think maybe we've got that graph that we can pull up in just a second. Charlie's been telling us about how much electricity is needed per typical school day. So that's the question that we wanted to answer. So that's great that you've got to that point.
And Ava from St Columbus is also looking through the data as well. Thanks very much for taking part, Ava. Lots of people joining today as well. And some people I can see just starting as well. Hello to Russell from Prestwick Academy working through the activity too. And Luca as well has been analysing the results. So Daniel, why don't we do a bit of, what could be more exciting than us doing live data analysis on the live stream?
So here is a plot of a high school in Dundee. So this is Braveview Academy, and we found this is quite a typical school. And what this graph is showing you is this is showing you the amount of electricity used each day. So each dot represents the amount of electricity used on that day. And we've got every day from the 1st of November up to the end of December. And Craig, it looks like it's quite high for 5 days in a row. And then it drops right down for 2 days in a row. And looking at the dates, I know that those lower days are the weekends. That's Saturday and Sunday. The electricity used is much lower.
So I guess the question is, why have we got that pattern? Why is less electricity being used at the weekend? So we asked you this question. We said, what do you think might be the reason that the electricity is lower at the weekend? And I've got some of your answers here. So Primary 6B from Ball Green Primary, they said it's because there might be less people in the building. Good answer. Riley
from Langley Primary because schools are off at the weekends, so that means that less electricity is used. And Lewis from Prestwick agreeing with that. I think less electricity is used at the weekend because there isn't kids at the weekend, there's only adults using the electricity, so there's less people. Louise also, she's from St Columba's High School, said less electricity is used at the weekend because there's no pupils to teach, which leads there to being no use in using too much electricity. Daniel, I think we've got a bit of a consensus here.
I think we have. I can see here that Louis is agreeing as well. They're not using electricity because there's no pupils there. Charlie at St Columba's has said because nobody is in the school. Devlin has said because no one is there. Yeah, this is a real consensus here. And you know what? I totally agree. I think that's because there's no one there. Like the lights don't need to be on, the projectors aren't on, the computers don't need to be on. There might just be a few janitors. So they're not going to be using nearly as much electricity at the weekend. And that's what we're seeing in this graph here.
I tell you what, Daniel, I bet these electricity and energy companies wish that they had 200, 300 data scientists just analysing all the results for them. That'd be pretty useful, and we should do this more often then. So we've looked at it across sort of a short period, but let's look at the numbers in a different way. So let's look at a graph that shows us maybe across a longer period of time, Daniel.
Yeah, so I've just zoomed
So the
out a
pattern
bit
here,
on our graph, and here you go, Craig.
yeah, so the pattern here looks a bit different, doesn't it? So this is, you know, it goes down for quite a few periods of time, and then it's that up and down, up and down, up and down, and then it's got down for a long period of time. Okay, so if we know that it tends to be lower numbers when there's less people in the school, what do you think these longer periods of low numbers are? Why does it suddenly go low during what looks like the middle of October? Why does it go low again round about December? And then why is it low between July and August? Daniel, what can you read into these numbers?
Yeah, well, I'm looking at the numbers when they're low, and you know, they're very consistent with what it is at the weekend. And we know that those numbers at the weekend, it's because there's no pupils there. So even though I don't know when the school holidays are at this high school or when they were last year, I think we can tell just looking at the data. It's quite obvious when there's no one in the building. So, you know, like I would guess that the schools went back around about the 12th or the 13th of August, because that's when it suddenly starts to spike up again after the end of the summer holidays. And it looks like, well, maybe some teachers were in the week before because it's a little bit higher, but it's nowhere near as high as it would be normally.
So what we're seeing here is, again, you're looking at these patterns, and what we're seeing is that those dips are because the school's on holiday, basically. And I can see that some of you are answering that question right now. You've been telling us when you think the school holidays are due to start in October. So the answer was the 7th of October. I think we can see that from that graph there. That's when it starts to dip down. That's when the holidays are starting. So some of you have already guessed that correctly. Well done. Well done for analysing that data. For those of you that didn't quite get it, well, the answer is the 7th of October as well. So I think, Daniel, we've done a really good job here of analysing the data so far. Are we just about ready to move on to the next phase?
I think we're just about ready. Let's have a wee look at our activity feed and see where people are. So it looks like a lot of you have worked out how much electricity is needed for a typical school day. So Corey, Grace, A and T, L, a lot of letters here.
Wow.
Your names might
Langley
appear shortly.
Primary of team, they've all appeared and went straight through the activity quickly. Well done, Langley. Kyle at Langley, well done for working that out, and Grace as well. So I think, Daniel, I think we're just about ready then to move on to the next phase.
Yeah, I think we're ready to move on to the next section of our investigation. So now that we've used an open data set to get an estimate of how much electricity a school just like your one uses, what we're going to do now is we're going to think about where that electricity comes from. Your school probably gets most of its electricity or all of its electricity from the grid. So the grid is a massive network of power cables that link the country together. So that's like schools, buildings, homes, offices, factories, even power stations, they're all connected to the grid. Now the grid is powered by lots of different sources. We've got things like wind, gas, coal, nuclear, and solar energy. And we can use another set of open data and we can look at live open data to see what's powering the grid right now. So Craig, let's take a look at what we call the energy mix.
This is interesting. So what are we looking at here, Daniel?
So what we're looking at here is a series of gauges, and it shows how much of our capacity for that power we're using in the UK. So the headline figures here are, well, we can see, let's look at this blue one in the middle on the left hand side. So this is for gas, and 59.4% of the electricity that we're using in the UK has come from gas power stations right now. And that gauge is really far around to the right, which means our gas power stations are almost running at 100% capacity. Whereas if we look a bit higher up at wind and solar, those gauges aren't quite so high. So that probably means it's not a particularly windy day, so we're not generating as much electricity by wind. And the same with solar. The sun's maybe not quite up to the top of the sky, and it's maybe a bit cloudy, so solar is not generating quite as much at the moment.
Well, I can see what's happening here just now, because I'm looking at that one at the top left, Daniel, and it's saying that, we're not using a lot of wind power at the moment across the UK, but when I look out the window, I can probably tell why. It's not a particularly windy day. If you were looking at this data set on a different day when it was really windy outside, that number would probably be higher. In fact, this isn't some sort of like hidden or secret thing. This is on a website that any one of you could go on and look at. So if you want to try this out later today, we'll be sharing the links to where you can look this up too. So the number that we've got that's quite interesting at the top left here, low carbon electricity, 27%. Now, Daniel, tell me if this is my understanding of this is right. So that means that 27% of the electricity generation in the UK at the moment is coming from low carbon sources. So things like renewable energy. And when we say renewable energy, we mean things like solar power, we mean things like wind power, hydropower.
Yeah, that's right. And that number also includes nuclear power, because nuclear power doesn't create emissions when it's generating power. So yeah, Craig, you're dead right. That number yesterday was really different. In fact, almost a third of our electricity came from the wind yesterday, and over 50% of our electricity was coming from renewable or low carbon sources. But that doesn't tell the full story there, just looking at the sort of UK wide view. Actually, depending on where your school is in the UK, that balance is going to vary a bit. It depends on what power stations you're closest to. So if
well, that's
you're
good to know, Daniel, because
sort of...
we've got people right across the country today. So there's people in the north of Scotland, and we've got people taking part from other countries too, or down in England as well, in Wales.
So we can actually take a look at another data set, and this data set shows the carbon intensity of the electricity that's being used in these regions. So when I put it up, have a look and see if you can spot your region and see how much carbon dioxide is being emitted for every kilowatt hour of electricity that's being used. Now, a kilowatt hour is just a unit of electricity. We'll come on to it a bit later, but it will give you an idea of how clean the grid is where you are compared to other places. So looking at it here, I can see if you're in the south of Scotland, where we are just now, or even if you're in the north of Scotland, the amount of carbon dioxide created to generate that electricity that's being used right now is really quite low. And that's because we've got lots of renewable energy up in Scotland. We've got lots of wind turbines. A lot of our buildings are starting to get solar panels. And also we have hydroelectric power stations that can get turned on. Whereas if we look down towards the bottom of the lid, we've got places like West Midlands, South Wales and the East Midlands. And I know that there's a lot of gas power stations down there. I think in the East Midlands, there's a big coal power station still being used in the winter.
It's great, Daniel. So this electricity that you're using has a carbon footprint. And one way that we can cut that carbon footprint associated with electricity in your school is to use some form of renewable source of electricity at your school. So we're talking about things like solar panels or wind turbines. So we asked you, does your school currently generate electricity? Let's look at some of those results, Daniel, if we can. We've not looked at a graph for at least 30 seconds. We better get another one up.
Absolutely. So this plot here, this shows the amount of your schools, whether they have wind turbines or solar panels or not. So I can see here that it looks like about, what would that be?
Looks about a fifth
Yeah.
of the school.
So about a fifth of the schools have a wind turbine or solar panels, and about 2/5 don't, and about 2/5 of you aren't sure if your school has a wind turbine or solar panels. And I suppose, unless, well, I suppose you had a wind turbine, you'd definitely be able to see it, but if you had solar panels, unless you can get on the roof, unless you climb up onto the roof of your school, you're probably not going to know whether you've got solar panels or not.
They're not always as obvious, especially if your school's got a flat roof. So we've been collecting that data as well. So thanks everyone who's been joining so far and sharing how they're getting on. Remember, you can tweet us at data_schools at Digital World HQ if you're an adult, and you can use the hashtag COP26 and you can use the hashtag DataSkillsLive. Daniel, we've got so many people working through this activity right now, answering all their questions, doing the calculations as well. In this part of the activity, what we're doing here is exploring the solar energy potential at your school. So the question that you're trying to answer, the question that you're asking of the data is, how much sunlight do you get at your school's location? Now that's really important, because if you're going to be using a solar panel, you need to know how much light there is that can be turned into electricity. So to do that, we're going to need sunlight data. So in other words, we need to know how much solar radiation lands at your school every day. So how could you measure that? Well, what technology could we use? We're thinking about, we're into green technologies, we're into using them. Well, what you could do is you could stand outside your school and you could use a light meter. So you could measure how much light there is right now. But to get, the idea for how much that would be over a whole day, you'd have to stand out all day, measure it every hour, and then you would have to do it for the whole week, and you'd have to do it all year as well. That is too long to be standing outside in the playground. So what is a better way of doing this, Daniel?
Yeah, well, we could use another data set here. So we had a look, and it turns out that NASA collects loads of information about planet Earth using their satellites. And they've got a data set that can tell us how much light falls on any location on the planet Earth across a year. So if we send NASA the latitude and the longitude, so the coordinates of your school, they'll reply with the data that we need, that sunlight data. But before we can use this data set that NASA have made, we need to know that latitude and longitude for your school. So what we've done is we've embedded a map into the activity so you can find the coordinates for your school. So what you need to do is find your school on that map. So either type in the village, the town, or the city where it is, and then zoom in until you find the building for your school or the campus. And then once you've done that, click on the building, click on where your school is, and it's going to drop a pin on that map, and it will show you the coordinates down at the bottom, ready for you to then submit them to NASA. Craig, how is it we actually send this data to NASA? Like, how does it get from our activity on your school network? How does it get across to America, to Langley and back again?
Well, to access that data set, we can use what's called an API. So an API is a way that a computer programmer can access data sets that belong to someone else. So we want to access that data set that NASA have. So to use it, we need to make a formal request. We need to ask for the data in a certain way. And then NASA will reply with that information. They will respond to that request. So to do that, we need to tell them the exact location that we want to know the sunlight data for. And we need to tell them that the year that we're interested in. So if we give that request correctly in the right format, then the NASA servers will respond with the data that we need. Now, you could do this just by trying to look up that information yourself on the NASA website, or you could email them and ask them to send you the data. But, that might take a while. We don't have a lot of time to do this. But by doing it programmatically, using an API, we should be able to get a response back from NASA in under a second. In fact, every school taking part in this activity right now should be getting a response from NASA's servers. And I'm pleased to tell you, Daniel, looking at it, it looks as if these responses coming back from NASA are only taking a couple of seconds. So that's really good. And I suppose that's good that we've set that up in that way to do it.
Yeah, so I suppose it's probably a good idea if we give a shout out to NASA's Langley Research Centre, because they've given us special privileges and permission to use the data inside our activity because our event is linked to COP26. So yeah, thanks to NASA for
Thanks, NASA.
for letting us use your data. I can see, yeah, like Craig, I can see too that loads of you have already sent your request using the API. I think we could take a look at a few of the plots.
Yeah, I was going to say, Stirling High School, hello to you. I know that you've been playing and tweeting us, showing that you've been putting yourselves on the map. That's good as well. Quite a few other schools, Daniel. Do you want to bring up the groups here? I think they're getting the data from NASA, I can see.
Yeah, so here is here's a graph from one of the pupils at Langley Primary, and I can see here that it looks like the solar activity peaks in May, and then it gradually falls over the rest of the year. So interesting that it's in May, Craig.
Well, I was going to say, let's talk about what we're seeing here. So this graph is showing us the amount of light across the whole year that it is arriving at Langley Primary School. So thank you for grabbing that data from NASA. And as you said, Daniel, what we're seeing here is that in some months, the amount of solar radiation is higher. So, April, May, June seem to be quite high up there. The further they are up that graph, the more light there's been. And Daniel, you said May is the sort of peak, it's the top month.
Yeah, May actually looks like it's the peak at Langley. And that might seem a bit surprising because you think, well, there's more sunlight hours in June than there are in May. Surely there'd be more solar radiation, there'd be more light in June. Well, actually, this data set it takes into account the weather, it takes into account clouds and other factors like that. So it turns out that actually May tends to be a drier, less cloudy month. So actually there's more energy arriving on the ground at your school. So, this data is basically, if you drew a square on the ground that was 1 meter by 1 meter, this is the amount of light that lands in that square across each of these months last year. But yeah, it's very level all the way from sort of April through to even August to September. Those numbers are quite high, actually.
Can we have a look at someone else? What other schools have been completing this, getting their data?
So here's another one. This is Linlithgow.
Yeah. So to me, the pattern there is quite similar, isn't it? So, in the winter months, October, November, December, January, February, it's a bit lower, and then it's rising to a peak again in May. So thank you for pupils at Linlithgow Academy for getting the data from the NASA API. And let me just look at the Linlithgow one for 1 second there, because I think it's probably similar, because realistically, Linlithgow isn't that far from Langley in terms of the size of the Earth, So the amount of light you get in Linlithgow is probably going to be similar to Langley. They're not that far apart. You had another one there, Daniel, as well.
Yeah, there's another one that I've got here. So this has come from Bayview High School in Karachi. So this is in Pakistan, and this one's interesting. So the numbers actually, the scale on the left-hand side, these numbers are a bit higher. It's not going from 0. This is starting at 4. So interesting. It's still May, where it's the peak, but it looks like it really dips down in August and then it goes back up in September.
Why is that? Like, does I'm just guessing, does Pakistan have like a monsoon season, or like a season where it's not as bright? I'm just trying to.
Yeah, you're exactly right. We can tell what the seasons are like. So it turns out there's a wet season, and that generally is round about August in that area. It's down near the coast. So yeah, we can see summer is definitely still around the sort of April to June, but then this amount of sunlight really drops and then it comes back up again, and then you can see winter is sort of November, December, January, and then it climbs quite quickly back up again.
Maybe I've got a career in geography after all, Daniel, if I can look at the data and work out where someone is in the world, or the way the climate is at that point. So we've got loads of answers here coming in. I think, Daniel, are we just about ready to move on to our next section of the activity? Let's continue the investigation in the next phase.
Yeah, so let's think about where it is we've got to so far. We've got the data about how much light, or how much solar radiation, I suppose we should say, falls on each square metre of land at your school's real location. But what we now want to know is how much of that solar radiation, how much of that light can we convert into electricity by a solar panel that could be used in your school? Now, solar panels don't convert all of that light into electricity. So we're going to need to do some sums to work out how much of electricity can be generated for every square metre. Now, Craig, while you're working through this, what I thought we could do is, we asked you another question at the start. We asked what changes you've made to help the environment. I think it might be quite interesting if we visit some of those while you're working through the sort of the questions about efficiency.
So Ruben from Stirling High School said that they're not wasting food and they're trying to eat greener. So that's what they're doing. And Emma from St Columba's High School said, I stopped leaving all the lights on. So Emma, truly reforming, they're not leaving the lights on anymore.
I can see Ava is trying to avoid wasting food and is litter picking. Amina at Stirling is active travelling. Grace at Langley is trying to save electricity by turning lights off when they leave a room.
I can see that Kyle from Langley is recycling. That's a good use. That's good as well. And Luca from Prestwick Academy is trying to use less plastic bottles as well. Now, Daniel, when I'm thinking about this here, like all of these are examples of things that you can do as an individual. So things that you can do from a personal level. And while that might make some difference, like what we're talking about here, that's more about change at a bigger level, isn't it?
Yeah, so there are lots of changes that we can all make in our lives that would make a really big impact on the climate. Things like flying less, using more sustainable transport options, thinking about what we eat and things like that. But there are bigger emitters that also we need to deal with, and that's things like where do we get our electricity from and where are things being shipped. And so thinking about electricity and where it comes from and the buildings that we use, there's huge savings to be made in the amount of carbon dioxide. So activities like this let us explore the problem, and we really need data science to help us break those down into smaller chunks that we can work through to find out the answers and the solutions to these quite big problems.
Totally. The impact that you could make by understanding the data and knowing how to use it could actually be making a change here that's going to affect, hundreds of, the amount of electricity that could be saved, the reductions in the greenhouse gases as well. So this is a way that we're using data science to tackle these sort of big challenges as well. So it's important to think about it at an individual level, but also what can we do from a large scale.
Let's take a wee look at our activity feed and see how you're all getting on. So I can see here that Hannah at St Columba's has calculated the amount of energy that can be generated per square metre. I can see that S has been measuring an area for their solar panel. And interestingly, L, who's at the University of Edinburgh, they've been choosing a model of solar panel. And thinking about the models of solar panels, you have a few different choices. There's different types of solar panels you could choose. There's photovoltaic, and then there's also solar thermal panels here. Craig, which panel do you think you would pick for this application if we're trying to power some schools?
Yeah, so we're looking for the panel to collect light, to turn light into electricity. So it needs to be a photovoltaic panel. So make sure that I can see some of you are answering that question right now. You're maybe misspelling it. So make sure you spell that answer very carefully. In fact, the best way that you can avoid making the mistake in that answer is just to copy and paste the word in so that you're getting that as well. So I can see that pupils from Stirling High School, Joseph, has been plugging in the numbers as well. And Charlie from St Columba's have started measuring out an area for the solar panel as well. And that's what we're going to be moving on to next, Daniel.
Yeah, so once we've chosen our type of solar panel, we then need to think about, well, what's the efficiency of that panel? How much of that light can we convert into electricity? And what you've discovered is, well, a lot of the panels on the market right now are about 20% efficient. So that means about 20% of the energy that comes in gets turned into electricity that can be used to power your school. So that's about a fifth. So
That's
what we
quite
need to
low.
do,
Like I would have thought that, when I was thinking about it, I was thinking, well, surely the people, the panels that are available might be something like, I don't know, 80% or 90% efficient. But to see it's like 20%, that's not very much. But I suppose that's an opportunity for us as well. Like maybe if we had more people who understand, we're interested in green technology, we're interested in physics or engineering, that perhaps they could be working on things, researching things to make it more efficient panels.
yeah, so although it might seem quite low, 20%, it is 20% of a really big number. So the amount of power that you can generate is still fairly decent. And it is an unlimited supply. It happens every day. It's very consistent. It's always available. But yeah, you're right, Craig. If we had more people working in this area, there's a lot of problems that need to be solved. If we could make solar panels cheaper, more people could have them. If we could make the efficiency better, well, we could generate more electricity, or you'd need fewer panels to generate the same amount of electricity. Now, there are solar panels in lab situations that can generate about 50% of the light that comes in, so about 50% efficient, but they're quite difficult to manufacture. So if we had more engineers and more people working in green technology, these are problems that are open, ready to be solved if we had more people working in this area.
So Daniel, we're almost there. Like I'm looking through the activity here. The next thing that we need people to do is to calculate the size of the solar array for their school. So how big are they going to make this? And if you were doing this manually, if you had to work out the size and you wanted to put this on your school roof, you would have to have some way of measuring that. So it might be that you would climb up onto your school roof with a trundle wheel and just walk around the edge. I wouldn't suggest you do that. That's pretty dangerous. But, we're technologists. How could we use technology to measure the size of our school roof? Well, we can use a geographic information system to help us. So in the activity, you've got another map, and it's really clever, this map, because what you can do is you can draw a shape on that map, and it will tell you the area inside that shape in square meters. So it's even got a data layer that will show buildings. So you need to draw around the area of your school building. You need to draw on the roof. So maybe there's a flat bit, or maybe you want the whole building covered with solar panels. You're going to need that for this next part of the calculation.
Yep, and this last bit of the calculation, but the reason why we need that number is, well, we already know how much electricity we can generate per square meter, but we need to scale that number up by how many square meters of roof you've got. So what you need to do is you need to multiply those two numbers together, and that's going to give us the final answer we need. That's going to tell us how much electricity could be generated by a solar panel on the roof of your school at your school's location. What are the real numbers? And do you know what, Craig? I'm seeing lots of numbers coming in, and it's really impressive. There's a lot of electricity. There's a lot of potential there.
There is. I'm so surprised. We'll maybe get some of these up in just a minute, but there's a lot of you are answering that just now. You're doing the calculations. Thank you to Aidan from St Columba's. You're measuring it out as well. Kyle from Langley is measuring it out too. P from Ballgreen Primary, you've been measuring it out, and L from the University of Edinburgh, looking like a pirate there with the eye patch, has plugged in the numbers as well.
I can see that Charlotte has been measuring an area of their school. So I wonder if you've gone for, a flat section. Have you gone for the whole school? Have you gone for even a bit of the car park? I don't know. It's up to you. You can choose how big you want to create your solar array. This is your chance to explore and play around with the numbers. And at the end, you could always go back again. You could restart the activity and work through it again with a different size thing. See what difference that makes to the numbers. But Craig,
Daniel, yeah. I was going to say, I'm interested, let's see these numbers that have been sent in to us. Have we got some ready?
We've got some that have been sent to us, so let's bring them up. Yes. So this is from Prestwick Academy, Craig.
Okay, right, okay, let me see this. So Prestwick Academy, if you put solar panels on your roof, you calculated that you could generate, that's like almost 1.5 million kilowatt hours over a year. That's a lot of electricity. So that could charge over 122 million iPhones. Daniel, I know my battery runs out quite quickly sometimes, but that's a lot of electricity.
That is a lot of electricity. In fact, it's so much electricity you could power 175 computing classrooms for a year. So I'm going to guess that was a really big solar panel, but if you've got a big roof, you know, why not cover it in solar panels, I suppose? Just like that shows how much potential there really is there. Or, you know, you could drive an electric car from Edinburgh to Dundee almost 100,000 times. And this is electricity you're going to get every year. And once the solar panel is installed, that's just free energy. It's there. It's ready to be used.
This is brilliant. Thank you very much, Prestwick Academy, for calculating that and sending it to us. Have we got another one?
Yep, so this is from a pupil at Stirling High School, and they've worked out that a solar panel on the roof of their school, for the size that this pupil's chosen, it's going to be 1.5 million kilowatt hours over a year. In fact, it's very similar numbers to Prestwick. I guess Stirling and Prestwick must have a really similar sized roof and a similar amount of solar radiation. Or maybe Prestwick gets more sun, so they've made a smaller array, and Stirling gets less sun and a bigger one. I don't know.
Well, some of the primary schools that are taking part, they might have smaller buildings, so you know they're not going to be as a big a number as that. But like Stirling High School, Prestwick Academy, they're quite large schools, so they're going to probably have large arrays if they were to fill their entire roof with it. So impressive. Okay. Oh, is this New York, Daniel? We're going to
yeah. So this is a college in New York. This is Manhattanville College, and whoever it is that's taking part from there, what they've worked out is just under 500,000 kilowatt hours every single year could be generated by solar panels on the roof of the building they've chosen. So what that's saying is they could power 59 computing classrooms, or this number at the bottom, over 5,676 10-watt light bulbs could be powered continuously 24/7 for a year. That's a lot of electricity, Craig.
This is brilliant. This is brilliant, and it shows you that, like, depending on where you are in the world, where the amount of light that you get, you're going to have different data. The size of your building, the amount of, you know, the size of the solar array will make a big difference as well. This is so impressive as well. Thank you very much, everyone, for sending this in. I can see Prestwick Academy, S1B and S1G, you're following along and sending these in. But Daniel, what if we were to work together here? So like, can you bring together everybody's numbers who are taking part right now?
Yep, we have a grand total. So I can see there's 13 different schools that are represented here. So taking one person from each school and thinking about the amount of electricity that could be generated, you've worked out collectively that you could power 25,610 light bulbs for a year.
Say that again?
25,610 light bulbs.
Okay, hang on. I'm going to type that in somewhere. Right. What is that? Like, I can't even think of how big that would be, but 25,000 light bulbs is a lot.
That is a lot. In fact, I think, are you creating a graphic right now, Craig?
I am.
You are
yes.
creating a graphic. I'll let you create that.
Can we have a look at it?
Yep. I think it's just arriving. Okay, here we go. Let's take a look.
So this is 25,610 light bulbs. This is representing the number of bulbs that if you were to put solar panels on everybody who's taking part school roof today, this is, you know, an estimate of how many light bulbs you could power for an entire year. That's a lot of bulbs, Daniel.
It's a lot of bulbs. We're about a quarter of the way there, by the way. And, you know, thinking about that a different way, we could think about the amount of carbon dioxide that could be saved by not taking that electricity from the grid, not taking that electricity that's come from gas power stations or coal power stations. And that number is 1.1 million tons of carbon dioxide. That's a lot of greenhouse gases that wouldn't need to be emitted if you were generating all of your electricity with renewable energy, such as a solar panel, like what you've just been specifying right now.
This is brilliant. Daniel, I've just done a little calculation there as well. That is the equivalent of seven and a half Blackpool Towers worth of lights.
A lot of lights.
It's the standard measurement for the amount of light bulbs. How many Blackpool Towers?
Oh, I see. It's a bit like double deckers, I guess, for height. Or yeah, I get it. So let's take a wee look at our activity feed again. Just to give you a few shout outs. So I can see here that Corey, Charlotte, Aaron, P, B, you've all been plugging in the numbers.
This is fantastic.
Adam. Thank you all for being part of our data science team. So everyone that's joining today, we couldn't have done it without your help. We couldn't have worked out the numbers for 13 schools that quickly. And I hope that this has got you really thinking about how we can use that data to reduce the carbon footprint of your school. Now, there is one last task that we need you to do, and it is an important one. We need you to answer a few questions about today's event and tell us what it was you thought. So take a look at your report card, and then you can press continue to answer a few questions.
So we're going to be running another live lesson later this month with Skills Development Scotland and Historic Environment Scotland called Defend Stirling Castle, where we'll look at what castles can teach us about cybersecurity. So if you've enjoyed this event today, hopefully you'll join us for that one too.
Yeah, I'm really looking forward to that one, Craig. And do you know what? I can't let this go past. We are on YouTube today. So, you know, if you could like the video and subscribe to the channel, what that means is you'll see all of our future activities whenever we get them planned. So, you know, if you've enjoyed this activity, you'll get a notification whenever we've got another live stream coming up.
So today's live lesson was part of a project called Data Education in Schools. So the Data Education in Schools project is part of the Edinburgh and South East Scotland City Region Deal Skills programme, and it's funded by the Scottish Government. So you can use data science skills to work in lots of different areas. So we're talking about it in the renewables sector today, but you can also use it in healthcare, agriculture, finance, tourism, the public sector, and even the creative industries as well. Data skills are important across all areas of science. So maybe you're thinking about working in physics or chemistry or biology or computing science. Having data skills will really be useful for working in these areas, because having the skills to understand data and use it to make good decisions, to make arguments, to inform things is going to be important in so many jobs. And there's lots of job opportunities in this area, Daniel, as well.
Yeah, according to Skills Development Scotland, there's over 3,000 data scientists employed in Scotland, and it's a really well-paid career option as well. The average salary for a data scientist in Scotland is about £52,000 per year, and that's almost double the average salary in Scotland. So yeah, it is a really well-paid option. So after today's activity, you could check out the dataskills.education website and join their newsletter, and you can find out more about data science in schools.
If you're a teacher or you're a parent, you can tweet us your final results or your report card to us at Digital World HQ and data_schools using the hashtag COP26 and hashtag Data Skills Live. We've had so much fun plugging in the numbers with you today, Daniel. It's been good. It's been so fun having like all these different schools taking part. If you enjoyed this and you want to try out other data science activities now, you could go to our website. You can try out Code Your Own Data Selfie, or you can try Defend the Rhino using data science to help protect endangered species. You just need to go to our website, cyberskillslive.com.
Well, thank you very much for joining us again. But for now, I just had to say bye from Sunny, who can't be with us right now, but I'm assured that she is. she was watching and she was helping you along. But it is also bye from Craig.
Bye-bye.
And it's bye from me as well. See you next time.
soon.